Everyone. So today we are going to talk about winter roads. Specifically, we're talking about how putting salt on the roads during the winter affects the environment. So we're going to go ahead and start with our warm-up. Our warm-up for today, which is on Google Classroom, is why do you think we put salt on the roads during the winter? What does the salt do? So go ahead and answer that on Google Classroom. And then we're actually going to talk about what exactly salt does to the ice and the snow a little bit later in the lesson. But today's agenda, we just did the warm-up. Next, we're going to introduce the road salt problem. Third, we're going to do a quick introduction to osmosis. Fourth, we'll do a quick activity about salt in various ecosystems. And then lastly, we'll do our exit slip. So today's focus question is, how do humans impact biotic and abiotic factors in an ecosystem? So the past unit about zebra mussels, our focus question was about how invasive species impact biotic and abiotic factors in an ecosystem. This unit and the next unit is going to be about how humans impact biotic and abiotic factors in an ecosystem. So after today, you will be able to explain how road salt impacts nearby ecosystems. So before we really get into talking about the road salt problem, in class today, I asked about how winters are here in Louisville. So I think you guys all remember, I'm not from Louisville, I'm from Michigan. And so some things that I asked in class were, what are your experiences with snow in Louisville? So what's the snow situation here? And what does the city look like during a snowstorm? What about after? So your classmates said things like, oh, there's not a lot of snow, or you don't have a lot of snow days. That's a bummer. That's very sad. But yeah, mostly I heard that there isn't actually a ton of snow. The snow doesn't stick to the ground. It might snow overnight, but then by the morning, the snow's already gone. So with all of that said about Louisville, now that we sort of have an understanding of what winters in Louisville are like, we can kind of talk about how salt might be used here in Louisville. And we can talk about how road salt affects snow and ice. So for the warm-up, a lot of people wrote that salt actually melts snow or ice. That's not actually true. That's a misconception. Salt doesn't actually do any melting. Instead, there's something else that happens. There's another way that salt affects snow and ice. We're going to watch a quick video that's going to do a pretty good job of explaining how salt kind of clears the roads for us a little bit. So the video is called "How Does Salt Melt Ice?" Again, salt doesn't melt ice, so the video title should be "How Does Salt Affect Ice?" But after we're done, we'll quickly think about how salt affects ice. So that's what you should be looking for in this video. All right. So, um, what are some ways that that the salt affects ice, or how does the salt actually affect ice? And the answer is that when the salt hits water, it breaks down into two different what we call ions, which are just basically really small molecules. There's sodium and then there's chloride. And the sodium and the chloride, they get between water molecules. So they actually prevent water molecules from coming together and freezing together because they're kind of in the way. Um, so yeah, so that's how salt like prevents water from refreezing. That's how it prevents water from freezing to a point. So we know that water freezes at 32 degrees Fahrenheit. So when we add salt to the water, the water can still freeze. It requires a far lower temperature. So at 16 degrees Fahrenheit is when the salty water will freeze. And so yeah, so just to reiterate, salt does not melt ice. Instead, the salt prevents cold water from freezing. So how exactly does it affect ice on the roads? So when there is ice, so ice does this really funny thing where the surface of the ice is constantly alternating between water and ice. So it's constantly freezing, it's constantly melting and then freezing, melting and then freezing, melting and then freezing, very quickly. So when you add salt on top of ice, again, the salt doesn't melt it, but the salt gets dissolved into the water when the top surface layer of the ice quickly melts into water. The salt gets in, and then it prevents that cold water from refreezing. So, so that's sort of how. So that's sort of how salt affects ice, and it can look like it's melting ice, even though it's not. So the most important point is that salt prevents cold water from freezing. And so when the salt gets in with the water, you guys remember from watersheds, water tends to move towards the lowest points in the landscape, in the land. So that water might carry away that salt with it into the nearest river or stream. How does that salt impact the environment? So we're going to watch another quick video. In this video, the person, he talks kind of fast, but he's going to tell you some of the ways that salt affects the environment. And then after the video, together we will list some of the ways that salt affects the environment. All right. So, so we just heard some of the ways that salt affects the environment. The main ways that the person in this video talked about were um, one, that salt increases the salinity of nearby streams and rivers. So salinity means saltiness. So streams and rivers are getting more salty, and that affects the things that live in them. Second reason was that the second reason is that moose, deer, and elk and things like that, animals like that, are attracted to the salt on the road. And so they come up to the road and they want to lick it off the road. And of course, if you have moose, deer, elk standing on the road licking the salt off the road, then you're going to have risks of collisions, of car crashes into the deer, elk, or moose. And though this doesn't specifically affect the environment per se, salt is it's also really corrosive. So it can break down roads, bridges, cars. It causes a lot of damage to them as well, which can impact our environment. So we mentioned how salt getting into the rivers and streams can affect the organisms that live there. How exactly does salt affect living organisms? That's the question that we're going to answer now. So have you ever eaten an entire bag of chips? Have you ever eaten an entire bag of chips? And if so, how did you feel afterwards? You probably felt really thirsty. Why? So the bag of chips you ate, so if you're anything like me, if someone puts a big bag of chips in front of you, you're going to accidentally eat them all. It just happens. It's not something you mean to do. It just happens. And so in my experience, after eating an entire bag of chips accidentally, you feel really thirsty. And that's because there's a lot of salt in bags of chips. And so to kind of answer this question, how does salt affect living organisms? We could even think about, ourselves. What happens when we eat a bunch of salt? We get thirsty. And the reason is because of the scientific principle called osmosis. So osmosis is a concept that you'll learn in high school. This isn't something I have to teach you about. So I'm going to give you the most basic definition of osmosis. But essentially, osmosis helps explain how water moves. So you might not know this, but water likes to move from areas of low salt to areas of high salt until both places have equal ratios of salt to water. What does that mean? So if we put a special, oh my God, what is this called? If we put a special boundary, if we put a special wall in the middle of a beaker or a cup, and on both sides of the wall, we fill it with water. On one side of the wall, we put a little bit of salt. On the other side of the wall, we put a lot of salt. So this wall right here, I called it a special wall, and that's just to not bog you down in the details. But this special wall, this special boundary, it lets water move through it, but nothing else. So what's going to happen is water is going to move from the side that has less salt to the side that has more salt. So if we look here, this side has less salt and now has less water. This side has more water or this side has more salt and now has more water. You'll notice the amount of salt has stayed the exact same. So there are 7 grains of salt on the left here. There are 7 grains of salt on the right here. So water wants to move until it's in equal ratios of salt to water on both sides. So here, there is a little bit of salt, so there should be a little bit of water. On this side, there is a lot of salt, so there should be a lot of water. So the water just moved across that boundary. The same thing happens in our body. So when you eat a bunch of salt, suddenly there's a lot of salt outside your cells. And your cells don't have that much salt, so water actually leaves your cells. Water leaves your cells and goes into everything outside of your cells in your body. and so that can cause you to be really thirsty because suddenly your cells don't have enough water. You need to drink more water. And so that's kind of osmosis at work. But if you don't quite believe me, we're going to watch a video that demonstrates how salt and how salt affects a living organism. So if we put a land plant in salt water, what do you think will happen? So we're going to watch a video of a person who put celery, a few stalks of celery, into a glass of salt water. And this person left the celery to sit there in that glass of water, glass of salt water, for 24 hours. And we're going to see what happens. Okay, so you just saw that the celery, it shriveled up. It started wilting a lot, even though it is in a cup of water. Well, it's salt water. And so we're going to watch this again, and this time I want you to look at what happens to the amount of water in the cup. I'm going to put my mouse at the level that the water started at, and we'll see how it changes. Okay, so where my mouse is right now, that's where the water started at. And as the celery started to shrivel, what happened to the water in the cup? It increased. How? Why? So, thinking about osmosis, celery has very little salt in its body. It doesn't really have a need for salt. So, celery has low salt. It's an area of low salt. This cup of water is 50% salt, so that's an area of high salt. So, thinking about osmosis, we know water wants to move from places of low salt to places of high salt. The water from the celery, it's actually leaving the cup. It's actually leaving the celery and going into the cup. That's why the water increased in the cup. So normally, if you put some celery in a cup of water, the water level in the cup is going to go down and the celery is going to become healthier. It's not the case when we put it in salt water. It's actually the opposite. The celery is going to wilt and become kind of sad and gross looking, and or rather just wilted, and the water in the cup is going to increase because the water is leaving the celery. So a few people asked, when we were talking about zebra mussels, a few people asked how, what would happen if we put a zebra mussel in salt water? And so essentially, zebra mussels are freshwater organisms, which means that they are adapted to live in freshwater. Zebra mussels, their bodies take in water just by being in water. So the zebra mussel is constantly exchanging water with its surroundings. When it's in rivers, then that's fresh water. If you take that zebra mussel and you put it in salt water, what's going to happen? So the zebra mussel is an area of low water. The salt water is an area the zebra mussel is an area of low salt. And the seawater is an area of high salt. So water is actually going to leave the zebra mussel's body. Even though it's in water, it's going to become dehydrated because it's in salt water. Its body is not meant for that. It's not adapted for that. And it'll dehydrate and then it'll die. It doesn't have enough water in its body. Who would have guessed? And the opposite is actually true if you for saltwater fish. If you take a saltwater fish and you put it in fresh water, it's the same thing. Saltwater fish, their bodies are adapted for saltwater. So they're also actively exchanging water with their surroundings. If you put them in fresh water, suddenly their bodies are places of high salt. And their surroundings are places of low salt. So water is actually going to come flooding into their bodies, and they could actually die of overhydration, if you can believe that. But there's one thing I wanted to clarify here. So there is some salt in most ecosystems around the world. And so salt is actually, it's a natural thing in an ecosystem. The problem is not the salt itself. The problem is changing the amount of salt in an ecosystem. So if we add salt to an ecosystem or take away salt from an ecosystem, that's when we run into problems. So of course, salting the roads during the winter, that's adding salt to an ecosystem, which is a big deal. So I just wanted to clarify that. So right now we're going to take a look at, so if you go into Google Classroom, there's a post called Lesson 17, Salt and Ecosystems Case Study. And the case study looks like this. So it's the first 3 pages are all fact sheets about how salt affects different ecosystems. The last page is a chart, and the chart has 6 different ecosystems on the left-hand column, and then the other 2 columns say, list at least 2 organisms that live in this ecosystem, and how will increasing salt levels affect the organisms in this ecosystem. What you're going to do, you're going to choose 3 of these ecosystems, and you're going to answer both of these columns. So for each ecosystem you choose, you're going to list at least 2 organisms that live in the ecosystem, and then you're going to explain how increasing salt levels affect the organisms in this ecosystem. All right? Again, you really have to choose 3 ecosystems. And please note, swamp and marsh, they're both on the fact sheet that says wetlands. So you'll see here wetlands, here's swamp, here's marsh. Right? So you should do that. And then when you are done, When you're done, you can go ahead and do the Lesson 17 exit step, which is also on Google Classroom. I will read I'll read the questions to you right now. So number 1 says, how does road salt affect ice? You have 3 options. Causes ice to melt. When the ice melts, the salt prevents it from refreezing. Or road salt cracks the ice on the roads because the salt is sharp. So which one of those is true? Number 2, what is osmosis? Select all answers that are true. Number 1, osmosis says that water moves from areas of low salt to areas of high salt. Number 2, osmosis causes land plants to lose their water when they are saltwater. And number 3, osmosis causes people to get thirsty when they eat salty foods because the salt causes water to leave the cells in our bodies. So, which of these answers are true? There are multiple answers. And number 3. For number 3, I'm going to give you a statement and I want you to explain why it's true. So the statement is, the salt level isn't the problem for ecosystems. The problem is changing the amount of salt in an ecosystem. So why is that true? How do we know that's true? I also want you to give specific examples. For the specific examples, you can look back at the worksheet that you just did, the Salt and Ecosystems case study. All right, so that is all for class today. Next class, we will continue talking about the road salt problem, and looking forward to seeing you then.